Hello everyone, my name is Alper Akgün. I'm an engineer at GitLab, and today I'll dive into Python language. I'll use GitLab Duo generated tutorial. As you all know, probably Python is a very popular language these days. It's the language of science and AI. It's a high-level interpreted and object-oriented programming language. It's known for its readability and flexibility. It has extensive libraries for number crunching, data science, but is also used in web development, artificial intelligence, and system scripting. I generated this tutorial using GitLab Duo Chat. I asked the Duo Chat, for example, to explain me Python variables, and I got all these results, all these tutorials into my presentation, and today I'll go through it. So installing Python, on most Linux systems Python is installed. I don't know the situation with Mac, but you can install Python, for example, using ASTF by adding the Python plugin and then installing a recent version. Here I installed the version 3.12.1. And let's go to my command line. As you can see, I have Python installed here. So what I'll do, I'll use nodemon hello pi to use nodemon to automatically evaluate my file here on my left, which I will use to type code and save. And whenever I save my code, as you see, it's going to execute that code. So let's start. In Python, you can write single line commands and multi-line commands easily using the number sign at the beginning. For example, let's write here a single line command, print hello world. Nothing changes here. And let's write here a multi-line command like this is a multi-line command. They should not change. They should not have any effect on the execution because commands are not executed. So let's go. In Python, you assign variables using the equal sign as usual. X equal 5 means I assign the variable, the number 5 to the variable x, and let's print the variable x here, as you can see on the right side. Here's my example, sorry. So here I assign the value 5 to the variable x and print it, and I can have a string variable and sign and print it. As you can see, x holds 5 and name holds John. So this is similar to other languages. Okay, we have already started printing values. As you see here, I have printed the value 5. I have printed the value name here, but let's do another example. Let's set x equal 5, and then let's print the value of x is x. As you can see here, I'm printing the value of x. And there's one more syntax in Python, if I remember correctly. Let's try. Yeah. So that string interpolation is done using the F formatted string here and with curly braces inside the string. How can I input values in Python? Okay. So as you can see, we have to import the sys library and then input a value, and then we can print it. So let's start. So what I will do, I will import, let's make this bigger, import sys name equals input, enter your name, and then print hello name. Okay, let's start this again. Here, hello Alice. Hello Alice. As you can see, that's how inputting variables values from the command line works. Okay, let's try something else here. Year, let's input year. Year equals integer conversion input, enter the current year. Okay, let me type here some space. Sorry, forgot the here we go. 2024. Okay, that works great, but let me print the year. Yeah, that's how it works. Let's print year +1. Yeah, so I converted the inputted year value into an integer here, and then printed the next year by adding 1 to the year. Let's do some arithmetic operations in Python. So we can do like x equals 5 plus 3, y, this is the addition operation. We can do y equals 10 minus 2. Okay, here's the code. This is subtraction operation. As usual, we can do 4 times 5 and assign it to a, and then we can do b equals 16 divided by 4. We have the floor division, integer division. Let's print c here. As you can see, it's taking the floor, so it's 3. And if I do the regular division, it's 3.75. And then finally, we can take a number to the power 4. For example, 2 to the power 4 is 16, as you can see here. So we have the basic math operations like that. We also have the modulus remainder operation, so let's print 17 and then modulo 7. I think that should yield 3. Okay, so I have to have parentheses in Python. Okay, here we go. That's all. So now let's go to code, and here let's again try print 17 modulo 7, and here we get it's 3. So we have the usual comparison operators in Python. As you can see, we have equal, not equal, greater, less. Let's try them all. Print 2 equals 2. True. Print 8 is not equal to 9, sorry, is true to. Print 7 is greater than 5, and that's true. And then x equals 7, and then print x is greater or equal to 7, which should be true. That's all for the comparison operators. Okay, we have the logical operators. As you can see, we use the AND and OR for logical operations, unlike in Ruby. In Ruby 2 you can use them, of course, and not true. Let's try those. So x equals 5, y equals 10. Let's print x is greater than 3, and which is false, y is less than 15, which is true. The end result will be false. Sorry, it's true. X is greater than 3, it's true, and then y is less than 15 is false. But let's make this a is greater than 13, and here we go, it's false now. And then I can negate that result, and it's true. And I can really get that and assign it to a variable z, which is a boolean variable, and it's true. So we have the usual control flow statements in Python. We have if, and then we have the for loop, then we have the while loop, and now let's do some examples for all of them. Here's my screen again. So number equals 10. If number equals 5, you see the indentation. So in Python, indentation matters a lot. Num is greater than 5. Here we go. You see the if operator. If checks whether number is greater than 5, and there's a logical comparison here, and then we print the result. Let's do a for loop for I in range 5, print I. Here we go. We have here a for loop, and we print out the numbers. And then let's do one final example, a while loop, while count is less than 5, print count, and then let's also increment count by 2. Here we go. As you can see, we have the final while loop here. We printed out even numbers and 0. Now let's go and let's learn list comprehension in Python. So it's a concise way to create lists, and here's an example here. And then here you go, we create square numbers. Let's give it a try. So I come to my screen. So okay, I think basic way to create a new list is it's called list, which is empty, and then for item in list, and then I will type if, okay, if I, okay, let's do it 3, if I is greater than 2, greater than or equal to 10, 2, let me, okay, let's create a new list which is empty, and then let me append the value to, okay, let's also get squared, the value squared here. Where did I go wrong? It's not defined. Okay, let's do this. Let's print list. Let's print new list. Here we go. So what I did is that I had a list with the numbers 1 to 3, and whenever the number was greater than 3, which is 3 only, I squared it and wrote it into new list. So this is the basic way of creating a new list. However, we have much more. So what we can do is that we can do squares as a new list, which is x to the power 2 for x in list. Print squares. Let's clean my screen here. Save. Here we go. So we had 1 to 3. Now we got 149. So list comprehension squared and generate a new list for me. Okay, so let's create something different now. Let's create a new list which is going to be x to the power 3 for x in range 10. Print new list. Here we go. I took x to the cube. Let's do some logical operations here in the list. So let's say I want to get even numbers as x for x in range 10, 10 if x mod 2 equals 0. So print even nums, and let me not print. As you can see, I printed even numbers including 0. That's list comprehension in Python. So let's do the dictionary comprehension. So this is a concise way to create dictionaries. As you can see, I have an empty dictionary, and then I iterate through an iterable and then create a new dictionary. And then, but there's another way. Here you create a new dictionary using that notation here. Okay, let's try. So what I want to do is that I want to get squares dictionary as x to the power 2 for x in range 10. Print squares. Here we go. So you see we have a dictionary which contains the square of every number from 0 to 9. Another example could be to get the word length. Let's say I have words, which is list of words: apple, banana. Okay, print. Let's print the word lengths directly as a list comprehension here. Word length word or word in words. As you see here, I got a new dictionary with word lengths for each word. And we have also set comprehensions, which are mathematical sets here. We can normally create a set and then add items into it. So that's the regular way. But we can create a square number sets here. Okay, let's give it a try. So create a set, all set. Let's add 5 set. So my set is 5. Now let me add 7, 8, 7 to my set, and let's add 8 again. As you see, the set still contains only one instance of 8. So that's all 4 sets. So tuples in Python can be created using that notation, regular parentheses, 1, 2, 3. And then you can actually get the values out of the tuple and then print them. Let's give it a try. So tuples equals 1, 2, 3, A, B, C, tuple, print A, And let's see what it's going to give me. Tuples. A is B is 2. As you can see, I'm able to extract the value, the second value, into B here. In Python, functions are defined using the def keyword, similar to Ruby language, followed by the function name and parentheses. Here's a greet function, and here I'm greeting. So let's give it a go. So let's try this. So def greet name print hello name. This is my function, and then I will call my function using Alice. Hello Alice. This is how it works. 1 second. I'm coming back. Okay, I'm back. So I called my function to greet Alice that way. Let's greet Bob. And here we go. As you see, in Python the indentation here matters, and then we have the column here at the end of the definition of a function. So basically that's how we define functions. So in functions you can return a value in Python. As you can see here, we are returning an expression or the summation of A and B. Let's do that example here. So def sum A B, return A plus B, print sum 1 2. So you should get 3 here. Yeah, here we go. Okay, if we don't use a return keyword, you see we end up with none. So that's very different from the Ruby language. In Python you must explicitly return, otherwise you'll return none, which is nil value in Ruby or null in JavaScript. Let's go back to our presentation. So we have the following data types in Python. So we have ints, floats, strings, list, tuple, dict, dictionaries, sets, boolean, complex numbers, bytes, range, and sets. There's an example for each one of them here. So let's quickly give a try and make some examples. So let me try to create a list full of different types. I don't know if that will work. 14, 2, true, true with a capital, print list. Here we go. As you can see, a list can contain different types of values with different data types. So in Python we also have some advanced data types like tuples. Let's say print point equals 3 4, print point. As you can see, we can keep the points in space as a tuple here. or let's have a dictionary. Name Alice, age 32. Here we go, we have an Alice dictionary. In addition to that, we have sets. So we have a lot of different data types in Python. So now let's work with some built-in functions in Python from different libraries. Let's start here. Print is -5. Yeah, ABS is available in the global namespace and the absolute value of -5 is 5. Let's print the mean value of 2, 4 and -1, which will be -1. Here we go. Similarly, let's print the max value, which is 4 here. Surprisingly, in Python we also have sum, which didn't work as expected, but let's give an array into it. 2 plus 4, 6 minus 1, 5. Yeah, here we go. So we can sum things. And finally, let's use sorted to sort an array. Here we go. That sorted my array. Okay, let's go to my presentation. So let's check some built-in modules in Python. So modules provide useful functionality for system interactions, math operations, random number generation, and then interfacing with the operating system, etc. So let's do some examples here. Here we have the sys module, and if we now print sys version, it's printing the Python version here, 3.12.1. Awesome. Let's import math, and let's print math square root of 16. Here we go. We got 4.0. Let's use the random module and then print some random integers in the range 1 to 10. Here we got 6. Let's try again. 9 and 10. So those are random values. Okay, let's try the OS module, and then let's print get current working directory from OS. Here we go, that's my current folder. And then we have the datetime module, and then today equals datetime dot now, or I'm not sure. Let's see. Very strange. Here we have to literally write datetime.now. So we have here we go, we have datetime.data.today in the same namespace. Let's go on. So exception handling. Similar to JavaScript, we are using try catch blocks in Python. So let's do some examples. Let's try. Then let's try to divide by 0. Now let's catch an exception here, and 0 division error exception, and then print cannot divide by 0. Here we go. As you see, we can try a block of code and then catch a certain exception, and then we can print a value. Of course, we can catch generally unknown error. Will that work? Let's see. I think that will work. In Python we also have else clause, where we can write no problems found. That doesn't work now, and let's divide 10 by 2, which is the valid expression, and then using the else statement I was able to catch that. I was able to catch the fact that there was no exception. Interesting. So let's go to my presentation. So in Python we have the enumerate function, which is used to iterate over a sequence, get the index position at the same time, and then we have filter, and then we have map, similar to Ruby and JavaScript now. So let's give it a try. So let me start with some names in an array. Alice, Bob, Jane, and then for index name in enumerate names, print index name. Here we go. As you see, I'm printing an index and a name at the same time. Let's get numbers. Okay. Can I do that? Let me see. Print filter. What exactly? Lambda x divided 2 zeros is an even number, so I'm trying to filter even numbers in the range 10. Will that work? I'm not sure. Okay, print. I should, I think, convert it to a list. Here we go. So we printed here the even numbers, and let's try to print the odd numbers. Okay, here we go. So as you see, I can filter a range and then convert it to a list, and then let's comment this out, and then let's say I have numbers, a range from 0 to 4, so squared is a map which gets a lambda x to the power 2 nums. So that's, and then let me convert it to a list and then print out. Let's see. Oh, I have an error, nums. As you can see here, let's do that again. Here we go. So I got a range from 0 to 3, and I was able to square them using map. So that's how map works. Let's go to our presentation, and then let's talk about Python collections. As you see, you can organize data in different ways in Python. So lists are ordered sequences that can contain duplicate values. Tuples are similar, but they are immutable. Sets only contain unique elements with no specific order. Dictionaries are they store key value pairs for efficient lookup. So they all provide different. They are all good for different use cases. So let's create some, examples here. Let's create fruits. So here I have a fruits list, colors, this is a tuple, colors equals, sorry, print fruits. So this is a list of fruit names, and then we have color names as tuples, and unique nums equals 1, 2, 3, 3. Let's see what will happen here. Here we go. As you see, 3 is deduplicated. And finally, we have a dictionary. Here we go, that's a dictionary. So those are all collection types in Python. So now let's go to object-oriented programming using Python. As usual, in Python you can define classes, you can do inheritance, and then you can override methods here. And you can have private and public members, etc. So let's give it a go. So let's first define a shape class. Underscore init is the constructor in Python, and you have to give self as the first argument for instance methods. Let's say self.name equals name. Let's create a shape. Shape1 equals shape So we'll give here a name. Say it unknown. Let's try to print shape, whatever that means. So we got an object here. If I want to print the name of the shape, will that? Yeah, it prints unknown. So this is the way you define a class. Def area, return none. I think that will work that way. So this one is shape unknown, print this one dot area. Here we go, we got none here. Now let's define a circle class which is inheriting from shape. It has a different constructor, radius. Yeah, that's better. And then let's call the constructor or the super class as circle and self.radius. Let's store the radius in that variable. Now area, let's define the area method which should return, let's do it simple, it should return 3.14 times self.radius to the power 2. Now, will that work? Okay, let's make C equals circle 3 and then print C dot area. Okay, we have some faders here. Circle. So we have there in line 14, then line 9. Here we have a problem. I was hoping, yeah, I could call the super, yeah, that's how you do it. You have to give super as a method call, and that will give the area of the circle with a radius of 3. Let's go back to our presentation and then let's do some file operations. As you can see, you can open a file using open here for read only, and then you can get the contents of the file and print it. Or you can write into the file something and close it. Similarly, you can open a file and print each line there. So let's give it a go. Okay, let me first open a file for writing, so that open example.txt for write as file. Lines equals hello world. File dot write lines. Will that work? Write lines. No, that won't work. Here we have a problem because we have a capital L here. Okay, here we go. So let me stop Python and let me try to see if, yeah, here we go. We have the example text created here, and we got hello world inside. So now let's open and read that file. That should print out, yeah, all the lines in that file. Okay, there's another way. So what we could do is that we could say contents equals f.read print contents. Here we go. That read the contents and then printed that out. So now let's see how we can work with directories. As you can see, you can use the OS module for that. You can create a directory and then list files in that directory. Okay, let's come back here. Let's come back to our code and let's do some examples here. So first, let me get the attributes of my file which I just created, example.txt. I have to import the OS module for that, and let me print attributes. Here we go. Those are the attributes, operating system attributes of the file. Okay, let's keep that. Let me get all the files in the current directory. List here. So in the current directory I get all the files and I print them out. Here we go, that's an array of all the files in my current directory. Let's go on. Let me create a new directory. Make dir new here. Did it work? Let me try to see all the files, and as you see, my directory appears as a file there in this list. Interesting. Okay, let's go back to my presentation. So regular expressions in Python is, you know, you can use the re module to import some methods useful for regular expressions. Let's do some examples here. So I import the re module, and then let's get a pattern A to Z, let's say. Only small letters, plus string. Let's get a string. Hello world as an example. And now let's match search pattern string and print the match. Okay, nothing matches. What does that mean? Okay. Let's define, then here we go. The match returns none. What does that mean? Okay, let's try a different method. Matches and all pattern string. Let's print matches, and here we go. We have again nothing matching. Aha, here's my problem. Okay, as you see, now my regular expression is fixed. I can get the matching object, which is hello here. Okay, that's useful to extract split values out of a string. So that's all for regular expressions. Let's work with some JSON data. So you can use the JSON module for that. You can convert, load a JSON string or convert data into JSON. So let's do some examples. Import JSON. JSON string equals, let me get this. I copied that here. Okay, then let me data equals JSON that loads JSON string. Then let me print data loads. Here we go. So I converted the JSON into a Python dictionary. So I can write that value into a file. So I open a file, JSON. Okay. For writing, f JSON.dump data into file. I think we have trouble here. It's restarting because I'm writing in the current folder. As you see, I have a JSON folder here. So finally, Python has a concept called decorators, which is a special type of functions which can modify or extend the behavior of another function. So that's useful to add additional functionality around the functions, such as logging, error handling, authentication. Look at the example here. So we have the add function, which returns x plus y. And when you print, you just print it. But here, the log function is used as a decorator here, and the log function is defined as a wrapper around that function, which then gets function and then before that prints some values around it. So decorators are very useful in Python. That's all. So you can, I'm sharing this link under the video, and I'm sharing the current presentation under the video on GitLab. So you can use that link to learn, to find a lot of resources to learn Python. Thank you very much.